So we are doing FTC apps today. Example 1 says the graph of a continuous function f with the domain from 0 to 8 is shown. Let h be the function defined by h of x is equal to the integral from 1 to x of f of t dt. So anytime that you see this notation, you should think this is the fundamental theorem of calculus. And the key to working these is to write down the key. Because of the fundamental theorem, I can say that h prime of x is equal to what?
F of t of dt.
F of x.
Oh, shoot.
I take the x and I plug it in, and I multiply by the derivative of the bound. And if this is true, I can say that h double prime of x equals f prime of x. So this right here, you must, I'm not going to say you must, you will lose points if I do not see this little key on your paper. Okay, write it down. This is the whole key to working these problems, because they're probably going to ask you one of three things. They're going to ask you about h of x, they're going to ask you about h prime of x, or they're going to ask you about h double prime of x. No, they will not. Okay.
Wait, so what's h of x?
H of x is the function that is defined by the value of this integral. Okay. So here we go. It says find h of 1. So h of 1 is, I'm going to use the original function that they gave me and plug in 1 for x. So it's going to be the integral from 1 to 1 of f of t dt. And I know that that value is 0. Part B. Is h of 0 positive or negative? And justify your answer. Well, h of 0 is going to be the integral from 1 to 0 of f of t dt. And if you look at the graph, the area under the curve from 0 to 1 is positive. However, since the function is defined as beginning at 1, I am moving backwards from 1 to 0. Therefore, it will change the sign. And so the value of the integral from 0 to 1 is therefore negative. So this is negative because we are integrating from right to left under a function that is positive for that interval. So the area under the curve from 0 to 1 is positive, but because my bounds are reversed, I'm moving backwards, and that will change the sign and the value from positive to negative. So part C, find the value of x for which h of x is a local maximum. Write an expression to find the maximum. Okay, so the first thing you need to do is justify it. H of x has a max when, how do we find a max? When the first derivative is or
Undefined.
and from, yes, okay. So h of x has a max when h prime of x. And what's h prime of x equal to? It's equal to f of x is 0 or undefined and changes from positive to negative.
Can we not just look at the graph?
That's what we're about to.
So why are we like, I'm confused. Why are we talking about prime at H prime?
Because they ask, okay, here's where I think that you are confused. They're asking about, this is not a graph of h of x. This is a graph of f of x.
Oh.
Got it?
Yeah.
We're trying to find a maximum for h, not f.
Okay.
And so this is why I need the key, Jacob, right here. H prime of x is equal to f of x. So look at this graph. Does the graph have holes or asymptotes?
No.
No, therefore it is not undefined. It is equal to 0. It's equal to 0 right here, and right here. Okay, so does it change signs at 1? No, therefore it's not a max. Does it change from positive to negative at 4? Yes, it does. And that's an endpoint, okay, which I'm going to ignore for right now because it could have a max at the endpoint, right? But I'm not going to worry about that right now. Okay, so I said since h prime of x, which is equal to f of x, equals 0 and changes from positive to negative at x equals, we said it was at x is equal to 4. There is a local max at x is equal to 4. Okay, so part D says find the value of x for which h of x is an absolute minimum. So in this case, I want to find the very lowest value, and we can have a minimum either at the critical points or at the endpoints. So I'm going to say h of x has a min when h prime of x, which is equal to f of x, equals 0 or undefined, and changes from, this time, changes from negative to positive. So if you look at the graph, it is equal to 0 at 1, and it's equal to 0 at 4. At 1, it does not change signs. At 4, we already said it was a max. So there are no interior points that meet this criteria. So I said there are no interior points that meet this condition. So if that's the case, I got to check the endpoints. All right, it's like a consider list. I got to make my consider list. Therefore, consider the endpoints. So I need to find the value of h of 0. And I need to find the value of h of 8. So I'm finding the integral from 1 to 0 of f of t dt. And we already looked at this in the previous problem. And we can see that there is a small negative value. So it could potentially be the absolute minimum. However, if we look at the value of h of 8, So look at this. We start right here at 1, and then this is where the max is at because there's a net positive area. But then this area below the curve is negative, meaning that there is more net negative area at this endpoint because of all this negative area under the curve. Therefore, my absolute minimum will be at the endpoint of 8. Okay, so this is going to be the integral from 1 to 8 of f of t dt. And there is more negative value. You compare the areas under the curve. Therefore, we have an absolute minimum at x is equal to 8. So part E. Find the x coordinates of all points of inflection of the graph of h of x. So how do I have a point of inflection? It's where that's true. It's where it's where the second derivative is 0 or undefined, and it's got to change signs. So I'm going to say h of x has a point of inflection when h double prime of x, which is equal to
H prime, F prime.
f prime of x, is 0 or undefined and changes signs. So we are going to look at the slope of the graph because it's equal to f prime. And we want to look where it has a horizontal tangent or perhaps a corner, and it changes signs. So at x is equal to 1, the slope appears to be 0, and there's a change in slope from negative to positive. Same thing at 3, same thing at 6. We are approximating here. We don't know for sure, but it looks like, right, that there are horizontal tangents at 1, 3, and 6. Therefore, we have points of inflection at those points. So since h double prime of x, which is equal to f prime of x, equals 0 at, I'm going to say, and change the signs. At x equals 1, 3, and 6, there are points of inflections at those points. Okay, so take a look back over the first page there. Are there any questions, anything that you would like to clarify on the first page?
Why you write it as from 1 to 0, where h is 0?
Because the function is defined at the beginning, starting at 1, going from 1 to whatever x is.
Okay.
That's 1. All right, here we go. We're just doing 2 questions today.
Thank you.
We finished the first one.
First one was better. So,
Example 2. Given f is the differentiable function whose graph is shown in the given figure, the position at time t in seconds of a particle moving along a coordinate axis is s is equal to the integral from 0 to t of f of x dx meters. Use the graph to answer the question. So the first thing that we do is we make our key. So I can say that s prime is equal to, not f of x in this case, but f of t And since they give me S, which is the position graph, the derivative is
See it again?
the derivative of the position is velocity. So this is the velocity. And it stands to reason, therefore, that S double prime is going to be F prime of t, and that S double prime is the acceleration. So I think that they're either going to ask me something about the position, something about the velocity, or something about the acceleration. Part A, what's the particle's velocity at t is equal to 5? So I want v of 5, which is equal to s prime of 5, which is equal to f of 5, which is equal to what?
S prime of 5?
S prime of 5 is equal to f of 5, which is, look at the graph,
2.
2. What are my units? Meters per second. It's a velocity, meters and seconds. Part B. Is the acceleration of the particle at t is equal to 5 positive or negative? Okay, so I want A of 5. A of 5 is equal to S double prime of 5, which is equal to F prime of 5, which is the slope of the graph at t is equal to 5. And so if I go to 5 and look at the slope, my slope is negative. Therefore, at 5 seconds, the acceleration is negative. All righty. Part C, what is the particle's position at t is equal to 3? So I want S of 3. And so this time, if I'm finding position, I'm going to use that original equation that they gave me. So I want the integral from 0 to 3 of f of x dx. So how do I evaluate the integral from 0 to 3? I'm finding the area under the curve from 0 to 3, which is a triangle.
Ooh.
So we got 1/2 the base times the height, which is 1/2. My base is 3, and my height is also 3. Therefore, that will give me 9.5.
Whoa.
So 4.5. And what are my units? Meters. Because it's the position. Part D. At what time during the first 9 seconds does S have its largest value? Can you find the largest value?
It's,
So I am looking for what in this question? I'm looking for the absolute
value.
max. So I'm going to say S has a max when S prime, which is equal to f of t, is 0 or undefined and changes from positive to negative. So let's look at the graph.
Okay.
The graph is not undefined. The graph is equal to 0 at 6. Does it change from positive to negative?
Yes.
Yes, it does. Therefore, I have a local max there. Okay, so I said since S prime, which is equal to f of t equals 0 and changes from positive to negative at t equals 6, there is a local max. But I've also got to consider the endpoints because I could have a max at the endpoints. Okay, so consider the endpoints. And to do that, I'm going to find S of 0. S of 0 is the integral from 0 to 0, which is 0. Therefore, it can't be the absolute max. And I've also got to consider S of 9, which is the integral from 0 to 9. Is the value of the integral from 0 to 9 positive or negative? How do we know? There's more net positive area than net negative area. Is it greater than the net area at 6, however? No, because we are subtracting off this negative area. Like if I were to put numbers on there, I'm just estimating here, but let's say that that's like 15 and that's 5. This would be positive 15 and this would be negative 5. Therefore, the value of the integral from 0 to 9 would be 15 minus 5 or 10. And the value of the integral from 0 to 6 would be 15. Therefore, it has its absolute largest value at 6. So I said the integral here from 0 to 9 is positive, but less than the value at t is equal to 6. Therefore, t equals 6 is the absolute max. And let me go back and answer this question. It says, can you find the largest value? In other words, can you find S of 6? If so, tell me what it is. If not, tell me why not. What is S of 6?
You cannot find it. Yes, you can. No, you cannot.
There's curves to the line.
Well, we found S of 3, right? How do we find S of 3? It was the area under the curve, but since this right here is abnormal, it's not an easy geometric shape, we cannot find the absolute value. Or excuse me, we cannot find the absolute maximum value, the largest value at 6. So can you find the largest value? This is no, because the shape is abnormal. The integral from 0 to 6. We're almost done. Hang on. So here we go. Approximately when is the acceleration 0? Okay, so the acceleration equals 0 when S double prime, which is equal to F prime of t equals 0. According to the key that I wrote at the top of the page, top of the problem there. So I'm looking at the slope of the graph. I'm looking at F prime. Where does it appear to be 0? At 4 and at 7. So this is at t equals 4 and at t equals 7. So then, let me write myself a little note here. I said F prime of t equals 0. Look at the slope. It says, where is the particle at the smallest time? So there's 2 times. One is 4 and one is 7. The smallest of those is 4. What am I finding if it asks where is the particle? That is the position. So I want to know S of 4. S of 4, I'm going to use the original equation that they give us with the integral. That's going to be the integral from 0 to 4 of f of t dt. Can I find the integral from 0 to 4? I could not find at 6. I can find it at 4 because it makes a triangle. It's got a base of 4 and a height of 4. So that's going to give me 1/2 the base times the height. Or 8 meters. That's where it's at. All right, part out. When is the particle moving toward the origin and when is it moving away from the origin? Okay, so which of these three things, position, velocity, or acceleration, would I use to determine this? It's going to be the velocity. However, there's something else that is relevant. It also depends on where the particle starts. Okay, so the velocity is either moving to the right or to the left. If the velocity is positive, it's moving to the right. If it's negative, it's moving to the left, right? But if the particle starts at -3 and then moves to the right, it's moving towards the origin. If it starts at -3 and moves to the left, then it's moving away from the origin.
So when it's your kind of origin, that's the point that it starts talking about the 0, 0.
I'm talking about at 0, yes, okay? However, I need to find the position. So I want to find S of 0, and S of 0 is equal to what? The integral from 0 to 0, which is 0. Therefore, I know that the particle starts at the origin. So no matter which direction it moves, it's going to move away from the origin at the very beginning. The question is it moving to the right or to the left, and how do we know? Well, I'm looking at the velocity. And what's the velocity? The velocity is S prime. And S prime is f of t. And so from 0 to 6, f of t is positive because my graph is above the x-axis. Does that make sense? Remember, excuse me, to find the velocity at 5, we're just looking at the graph, and it was 2 here because it's above the x-axis. The acceleration, on the other hand, was the slope. So I know that it starts at the origin and S prime of t, which is equal to f of t, is greater than 0 on the interval from 0 to 6. Therefore, the particle moves away from the origin on this interval. So it starts at 0, and then for the first 6 seconds, the particle has a positive velocity because it's above the x-axis here. So it's moving away from the origin. And then at 6, what happens? It changes direction because the velocity is 0 and there's a sign change. So from 6 to 9, the velocity of the particle S prime of t, which is equal to f of t, is less than 0. So from 6 to 9, the velocity is negative. So the particle moves towards the origin. And one more. Part G, on which side of the origin does the particle lie at t is equal to 9? So I want to find S of 9, the position, which is the integral from 0 to 9 of f of x dx. So does the integral from 0 to 9 have a negative value or a positive value? Does the integral from 0 to 9 have a negative value or a positive value? How do we know? The net area is positive. This area here is greater than this area here. So this has a positive value. Therefore, the particle lies on the positive side. I'm going to say of the origin.